We are looking at L'Hopital rule. When can we use it? And that's what I want to explain in this case. What the summary of this law is saying is that if your limit of f of x over g of x tends to a, it is giving you 0 over, it is giving you minus infinity over minus infinity, it's giving you infinity over infinity. I want to knock this one out. You're having 0 over 0, infinity over infinity. We call it indeterminate. And that's why we say that L'Hopital rule says that under suitable condition on f and g, if limits of f of x equal to limits of g of x as x tends to a, and the value is what? Is 0. Or limits of f of x as x tends to a, is equal to plus or minus infinity, and limits of g of x as x tends to a equal to plus or minus infinity. So the summary of what we are seeing here is just here. And that will call for L'Hopital rule. What is this? He's saying that what led to this 0 over 0 or infinity over infinity? Okay, that fraction that led to this 0 over 0, infinity over infinity, you will differentiate it. That will be f prime of x over what? G prime of what? G prime of what? Of x. And that's what L'Hopital is saying, that this limit, okay, that led to the indeterminate, you differentiate that function, okay? You differentiate numerator separately, you differentiate what? Denominator. In this case now, we are not going to use quotient rule. You differentiate each of them individually, the numerator separately, the denominator separately. And that is the bone of contention in this aspect. You have your indeterminates, 0 over 0, infinity over infinity. Then you use L'Hopital rule. Yeah, evaluate the following limits. The first one, the a parts. So do your direct substitution. So if you do that, you're going to have 0. Here also you have 0. So this is called indeterminates. And when you have indeterminates, use what we call L'Hopital rule, and that will be equal to the derivative of this numerator, the denominator also, the derivative of the denominator. So this one is a product rule. I'm going to keep this one constant and differentiate the sign, okay? Then plus. Keep the sign constant and differentiate this one. So times what? Times 1. So do your direct substitution, and that will give you, this will be 2 minus 2, that's 0. This will be what? This will be 0 plus. This one also, that's 0. So that's what? Indeterminate. So apply your L'Hopital rule. Okay. In as much you are having 0 over 0 or infinity over infinity, then you must use L'Hopital. Differentiate again, and that will be limits as x tends to 0. Your numerator, differentiate that, that will be this over the denominator. Apply the product rule, keep this one constant, differentiate this one, that's minus sine x, then plus cos s constant, and differentiate this one times 1, and then plus what? Plus cos x. Then after that, do your direct substitution, and that will be what? 4 on the numerator. This one will be 0. This will be 1. This also will be 1. So you have what? You have 2. So that's that on the first part. The second one, do your direct substitution. It's going to give you 0 over 0. This is 3 to the power 0. That's 1 minus 1. This is called indeterminate. Apply your L'Hopital rule, and that will be equal to limits as x tends to 0. If you differentiate this one, you're going to have this all over. The derivative of arc tangent is 1 over 1 plus x squared. Then do your direct substitution, and that will give you ln, the natural logarithm 3. And that's the end of the second part of this question. Okay. If you're watching me for the first time and you're yet to subscribe, what are you waiting for? Why not smash the watermarks on this video and hit the notification bell so that anytime I upload, you get notified. Click on the like button and begin to type your comment. Finally, share the links of this video on all your social media platforms. You can also send me an email for one-on-one discussion, for group discussion. Send me an email. I'll put my email on the description of this video. Thank you. The third question. So do your direct substitution. You're going to have infinity over infinity. Apply L'Hopital rule. And that will be equal to limit as x tends to infinity. Differentiate your numerator. Differentiate your denominator. And that's equal to what? This one over infinity, that's 0. You have infinity. So that's the end of this video. We still continue. Because we have several cases of indeterminates. So please, the next video will be indeterminate of 1 to power infinity, 0 to power 0, infinity to power 0. So please watch the next video on those indeterminates.